Welcome to The Click. Today, let's solve some practice questions for ratios and proportions properties. But before that, we actually need to continue the proportions properties as we didn't finish them in the previous lesson. So starting with the sixth one, because we covered the first five in the previous lesson, starting with the sixth property of proportions. If you add or subtract the same operation in a proportion, it still stays a correct proportion. What does this mean? So if you play with subtraction and addition in numerators and the denominators, all of them, it's going to still be a correct proportion. And in fact, a ratio in a proportion with the first proportion. Do you get what I mean? So the value won't change. The value of the proportion won't change. So I really encourage you to, instead of alphabets, write numbers in here, and then it's going to be very clear and obvious for you that why this property works. But let's have an example for one of them, the hardest one. Let's have an example for that. So A, B, C, D. Let's have numbers for them. Let's clarify the numbers at the beginning, because I said to you that you should use numbers instead of the alphabet, because it's going to make it obvious for you, right? So let's do that. A equal to 1, for example, B equaled to 2, C equaled to 2, and D equaled to, for example, 4, right? Going with the simplest ratios. So A minus B, 1 minus 2, A minus B divided by A plus B divided by A plus B, 1 plus 2, equaled to C minus D, so 2 minus 4, divided by C plus D, 2 plus 4, right? Let's simplify this. So 1 minus 2 is equal to 2 minus 1, and 1 plus 2, 3. So the next one, minus 2 divided by 6. And if we simplify this, this is going to be minus 1 divided by 3. And this is why these rules and these relations work. So if you want to practice even more, so do examples for the other relations, like the first one, second one, and so on. The seventh proportions property is if we have three ratios, okay, a proportion of three ratios, and they are all equal to one number, which is k, our variable, our number k, or the result of them, or the value of them, or the number that they're equal to is called the constant of proportionality. What is exactly constant of proportionality? So let me give you an example, okay, for constant of proportionality at the beginning. So constant of proportionality. So I have, for example, one vase, and each vase of mine can contain 10 flowers. Now I can put 10 flowers in each vase, okay? So this is going to be the number of flowers, right, equal to 10 times number of vases, right? Number of vases. Vase is the thing, the flower container somehow, right? Sorry for the bad handwriting in here. I cannot fit it correctly. So the number of flowers equaled to 10 multiplied by, or 10 times number of vases, okay? So if I put x instead of number of flowers and put y instead of number of vases, it's going to be something like this. And this is an equation. We've built an equation right here and just now, right? And in this equation, 10 is my constant of proportionality. What does 10 do? 10 is a number, a specific number that creates a relationship between our variables, okay? So, makes the relationship between the variables obvious. So my variables are x and y, or numbers, number of flowers and number of vases, and 10 makes them obvious, makes the relationship obvious. So each flower, the number of flowers is equal to 10 times, y, or number of vases. So 10 is my constant of proportionality in here. So again, put numbers instead of the alphabet and it's going to be obvious for you. I'm gonna solve one problem for one of these relations. Let's pick this one, for example, the third one. So C plus E, D plus F equal to A divided by B equal to C divided by D equal to E divided by F. So firstly, let's name the alphabet, or write a number instead of the alphabet. So for example, for A, I will have 3. For B, I will have 5. For C, for example, I'm going to have 15. For D, I'm going to have 25. For E, I'm going to have 18. And for F, I will have 30. Okay? And let's just put them instead of their alphabet. So 2 by 2, these numbers are equal to 0.6, right? 0.6. So let's see whether this relation equals to 0.6 if I put the numbers instead of these alphabets. So C plus E, my C is 15 plus E, which is 18, divided by D plus F. So D 25 plus 30, right? So what's going to be the result? 15 plus 18, 33, divided by 25 plus 30, it's going to be 55. So let's do the division. I use the calculator because, we don't have time to do it manually, and the result is exactly 0.6. Look it up in the calculator and the result is 0.6, and this is a proof that this relation is correct. All the other relations are also correct because they're proven from the past, from other scientists, but I want you to instead of the alphabet, write numbers and really practice with yourself. Okay, the 8th one. In a proportion, you can simplify the numerators together and the denominators together. What does this mean? You know that we can simplify the numerator and the denominator, right? But in a proportion, we can simplify the numerators and the denominators together, and there's not going to be any changes. So for example, I'm going to have 15 divided by 25 equal to, for example, 18 divided by 30, right? And this is going to be 15, I'm going to simplify these two, 15, 18, and this will be 5, this will be 6, right? So 5, 6, 25, 30. And in fact, I can simplify the denominators with each other as well. So finding their GCF, 25 will be 5 and 30 will be 6. So this will be 5 divided by 5 equal to 6 divided by 6, which are all equal to 1, right? So because they're equal to 1, we know that this property is correct. Congrats, we're done with proportions properties, this long part, but the easy part. And now let's go and solve some practice questions for ratios and proportions properties. Let's add a property in here, so property. Okay, I have 5 questions for you. The first one. The ratio of two numbers is 2 to 3. If one number is 10, find the other number. So they say that one number is 10. We don't know which number is 10, but let's consider it like this. 2 divided by 3 equaled to 10 divided by x, okay? Using the cross multiplication, x equaled to 2. I can, write 2 in here as coefficient of x, or I can write it in the denominator part as well. So 2. 3 times 10 in the numerator, because they're means, 30 divided by 2, which will be 15, and x is 15. The number is 15. The second one, a quantity of 40 is divided in the ratio 1 to 3. Find each part. So this is proportional division, right? So for this, let's firstly add the parts of the ratio, 1 plus 3, which is equal to 4. And then secondly, divide 40 by the result. So 40 divided by 4 equal to 10. And thirdly, let's multiply the result by each part of the ratio. So 10 times 1, 10 times 3. This is very obvious, but these are equal to 10 and 30. So 10 and 30 are our answer. Okay, third one, find x. 3 to 5. 3 to 5 equal to 2x to 20. So I'm going to write the coefficient of x in the denominator, 5. 3 times 20, which is going to be 60, right? 60 divided by 5, which is equal to 12. The fourth question, check if this is a proportion. 4 divided by 6, or 4 to 6 equal to 10 to 15. I saw one student of mine using this answering method to see if it's a proportion. So I'm going to use the same method. I'm going to use the cross multiplication to see it. So 4 times 15 is 60, right? And 10 times 6 is 60. And because both are equal, we know that this is a proportion. Two numbers are in the ratio 47. If their difference is 15, find both numbers. So I have the ratio 47, and the quantities of the parts of the ratio, I can name them as 4k and 7k, right? Their difference is 15, the quantity, the difference of these two. So 7k minus 4k equaled 2 is equal to 15. 7k minus 4k, 3k, simplifying this, okay? 3k equal to 15. And the coefficient of k, the coefficient of unknown, I should move it to the other side of the equation. So k equaled to 15 divided by 3, right? This was the coefficient of k. And this will be 5. So the unknown is 5, and the quantities were 4k and 7k. So we only need to multiply it. 4k equaled to 4 times 5 equal to 20, and 7k equaled to 7 times 5, which is equal to 35. And the answers are 20 and 35. Yeah. Okay. These were the practice questions for this lesson, and we're done. Thank you for being with me. The sources for this lesson are one lesson from Khan Academy titled Identifying the Constant of Proportionality from Equation in YouTube, and the other one is the Arithmetic and Algebraic book. Thank you.